Now, let us swiftly go back to the add-on store and select the new add-on, the claim add-on. It's the same process. Select the claim add-on and click on update here. This time around, we can directly download the jar file without configuring the add-on. And here's the jar file. Let us take a look at another sample application that resembles a trust anchor. The basic logic is that I want to register for the same Hello World application, but this time around, there's a claim mechanism involved. I need to apply for a claim, which will then be verified before allowing me to proceed with the registration process. Now, we will check out a sample application that resembles a trust anchor. To register on my Hello World application, every individual needs to have a claim that is verified by the said trust anchor. So, the trust anchor has a system in place that can be used to apply for a claim that will be verified and then can be obtained and used to register on my Hello World application. So, this here is the claim template for our trust anchor application. That is for all the data that is collected using the form. Now for this claim application and verification process, there will be gas fee that needs to be paid. And this is the place where the public key of the claim issuer and the private key of the wallet account that will be paying the gas fee is specified. A claim issuer could be an institute or an individual, and in this case, it's the trust anchor themselves. The address of the RESTful API is specified, and finally, a new issuer object is created. Now here is the claim application action. Here, the data object is passed to the apply claim method. The data from the form is obtained from this object, and the new claim is issued by assigning the values to respective variables. Finally, the claim information is saved as such by instantiating a new claim object. Now, once the claim is verified, the user can fetch the claim using the QR code. Let us look at the getClaim QR code method. Here, an ID is assigned, which helps identify an instance of this action, the callback address for the application API, and the QR code string, which is composed of the ID and the callback address. Finally, this QR code JSON object is returned. A final success response is also displayed if no errors occur during the process. Finally, there is the claim callback action, which delivers the verified claim to the claim owner. It refers to the same callback URL that the QR code contained. And this is the section which we went through a few minutes ago, where the QR code was created. Therefore, using this callback action, the final claim will be fetched by the claim owner. And if we look closely at this claim callback method, here it verifies the signature of the account that is fetching the claim. If successful, a new claim object is instantiated and the claim data is stored in it. And this is where the claim content and details are specified. This is the claim result, so to speak. And here we specify the attributes such as the kind of claim it is and the purpose that it serves. Yes, this claim can help you register in Hello World. If the identity verification fails and an error is reported, it says identity verification failed. Oh, and an important part of the process is the verification itself. So the claim SDK is initialized here. Under the signing SDK, the parameters being the app name, a sample icon resource, and the claim callback address. The consumer object marks my sample Hello World application that will consume the claim, which is provided by someone who is trying to register on my application. This action over here receives the claim from the other user trying to register using this callback address. And this action here asks for the claim, a prompt, so to speak. It does this by carrying out claim authorization. The user data is obtained using the QR code generated using the string composed of the claim model and the claim issuer, which is the trust anchor itself in this case. A record of this action is also maintained using a claim object with an identifier and the time. The claim callback method, the action, carries out authorization. First, it checks whether the claim exists or not using the identifier that I just mentioned. It throws an exception if no such claim exists from the user. Next, it verifies the signature to ensure that the claim has been authorized by the owner. And it throws an exception if the signature verification fails. It then proceeds to verify the claim itself using this method, verify claim. And if the verification is successful, the record is set to state success and stored locally. This is what the update by primary key method does. Let us proceed to the demo of this claim mechanism.